Hello and welcome back to Differential Equations section 2.6, Forced Oscillations and Resonance. We're going to take what we learned in our non-homogeneous 2.5 section and apply it to the mass spring system with forcing term at the end. So for those of you who remember, the major equation was mx double prime plus cx prime plus kx is equal, it used to be equal to 0, now it's equal to f of x. So we're going to use this equation here to get our system described. Now we can have with and without dampening again, and again we can talk about the frequency, we can talk about the other thing, period. There we go. Can't remember all the words. So let's take a look at the first wonderful example that we have, say problem number 2. They just give us the equation because they want to make sure that we can actually work out initial conditions. So you can see the wave equation on the left hand side. That factors over complex numbers, which means that you have the trig solution to it, which means it's a wave. And you also see a wave forcing on the other side. It's a wave because it's a trig, right? Trig is a wave, right? So over here, we see the solution yh of t, xh, sorry, xh of t is c1 cosine 2t plus c2 sine 2t, because the r is plus minus 2i. There's no real part because there's no dampening, and we just have a wave. Now we can combine this into cosine with the phase angle and all of the other stuff. That's for later. So now we can work out either undetermined coefficients or variation of parameters. Yeah. All right, do it. Yeah, variation of parameters is that one equation which I believe variation of parameters goes faster, but then you can do undetermined coefficients as well. It's fine. I like variation of parameters because I can quickly, it's quicker to integrate, I think. So cosine 2t y1 prime is 2 sine 2t, and it needs to be negative. Over here we have y2 equals sine 2t, y2 prime equals 2 cosine 2t, and then the Wronskian over here is just going to go like that. So that's 2 plus 2 is, no, it's 2, right? Because cosine squared, so 2 cosine squared plus 2 sine squared is 2. So Wronskian is 2. I can put it on the side. And we can just work out the yp real quick. It is negative y1, which is cosine 2t, and then the integral of you're gonna love this. So sine Hold on, hold on. Life is not over yet. So sine 2t times 5 sine 3t over the Bronskin is 2 plus y2, which is sine 2t integral of cosine 2t times 5 times sine 3t over 2 dt. Well, now kick out 1/2, so we and 5, so negative 5/2 cosine 2t, and what you need to integrate is sine 2t sine 3t. Why I'm putting dx, it should be dt now. Yeah. Nope. Plus 5/2 sine 2t integral of cosine 2t sine 3t dt. Click. Ready? Quick. Quick. Ready? Product to sum formulas. Trig. Hello formulas. Yep. So what you do is the product of the two waves that have different wavelengths will interfere, but then to integrate those, we can convert this into single sines and cosines right there. And yeah. Sure, why not do it? Without bothering George. So now, I will switch back and forth to quickly come up with these things. Equals to negative 5/2 cosine 2t. And I have sine sine. Sine sine is the second one, so it's 1/2 cosine of addition, cosine of subtraction with a minus. Okay. Cosine of addition minus cosine of subtraction, but then cosine is just t there. dt, and there is a 1/2, so it becomes a 1/4 over here. Plus cosine sine. It's also going to be 5/4 sine 2t integral. These halves change into quarters because all of our formulas have 1/2 in front, right? So I need the cosine and then sine. So cosine times sine, sine plus minus sine minus, okay? So sine of 5t minus, when you subtract these two, it becomes plus cosine 5t dt. One more time to verify that. So cosine sine, sine, negative sine. Yeah. Beautiful. Negative 5/4 cosine 2t. And now I have the integral over here. So cosine is sine, and then over 5. So sine 5. Yes.
When we went through the one before, isn't that last integral, didn't you Reduce that cosine 2t sine 3t right above it from the previous one. Why is it going
This
back
one?
to 5? Yeah, why is it going back to 5 and 5?
Oh, you're right. It's supposed to be
I
a...
got that right?
Yes, you did.
Wow. Do I get extra credit on the test for that?
No.
For paying attention?
You get extra credit on the test when you do stuff on the test.
Can we draw a cat?
I knew it. That has to come up every time. So sine of negative t, sine is odd function, so the negative will jump in front, and that negative changes into a positive. Good. All right. All right, there we go. There we go. Yay. Well, we are yet to work with the derivatives to get the because we have the x of 0 is equal to 0. I forgot to write that over here, but x of 0 equals x prime of 0, which is 0. See? Now, to simplify, this y of p will take about an hour because we have to distribute each one of these and then use the formulas again to separate them. So yeah, let's do that. Over 5 and 5 will cancel. We get negative 1/4 cosine 2t. Don't worry, I got this. Sine 5t, and then plus 5/4 of cosine 2t sine t. So that is when I distribute the first. Now we're distributing the second one, so minus 1/4 sine 2t cosine 5t, and then a minus 5/4 sine 2t cosine t. Great. And now we do the formulas again to work out these cases so we can have all the sines and cosines. We actually don't have to use the formulas if you're okay with the product rules on each one of these. Formulas will actually help us have this to be single trig functions that we can quickly differentiate. So, you know, you pick your poison. That's what it actually is. I would rather use formulas. So cosine sine, switch. Cosine sine is 1/2 sine of addition minus sine of difference. 1/2 makes this 1/8. Sine of addition minus sine of difference. It was a negative 3, and the negative on the odd function jumps outside.
Yeah, what is that, sine 7t?
Sine 7t, yes. Do I need to zoom in?
No.
All right. Plus 5/8. And now we have cosine sine, which is the same thing. So we know it's addition and then the difference. So sine of 3t. And the difference is sine, so minus sine of t. Now the next term. Minus 1/8. Sine cosine. You go here. Sine cosine, sine of addition plus sine of difference. Sine of addition plus sine of difference. So sine of addition, which is 7t. And I said plus sine of the difference. It's going to make a minus. Sine 3t. And finally, 5, again 5/8 because of the 1/2 from the formulas. We have sine, cosine, so again sine of the addition plus sine of the difference. Sine of addition plus sine of difference, yes. Sine of addition, so that's going to be sine of 3t plus sine of the difference, sine t. Yes. So what do I have? The first two parentheses combine and add. No, everything adds here. All of the signs are opposite. I mean, all of the signs are the same, right? Everything adds. You have negative 1/8. Oh, the second part is canceling, yes. So negative 1/8, so that's negative quarter. Sine 7t. And then these guys die. Right? And then 5/8 and the negative 5/8 sine 3t, they die. But the other guys add because it's negative and negative, so negative 5/2, negative 5/4, sorry, negative 5/4 of sine t. Beautiful. Look at it, it's compact into after everything we did. So now we have our y of t is equal to c1 cosine 2t, if I remember. What happened? Sine 7t minus 5/4 sine t. We can finally differentiate, use our initial conditions to figure out C1 and C2. So y prime of t is equal to, derivative of cosine is negative sine, so negative 2c1 sine 2t, plus derivative of sine is positive cosine, so 2c2 cosine 2t. 7 jumps out as minus 1/7 cosine 7t, and negative 5/4 cosine t. Bueno. What we need to plug in is, why I put y? It should be x. It's x of t. So x of 0 is the same as x prime of 0. Oh, why? You use pens? Don't. You're in a math class. So plug in x equals 0. It kills all of the sine terms. So we get that the c1 cosine of 2 times 0 is equal to 0. And we calculate that c1 is equal to 0. So sine of 0 is 0. Sine of 0 is 0. Sine of 0 is 0. So all three terms die. And cosine of 0 is 1. So you have c1 equals 2. But we had 0 there. I hope. Let me check. Which problem are we working on? Problem number 2. Yep. There we go. Now, for the second equation, we have all of the terms again with a sine die, and all of the cosines survive. So we have 0 is equal to 2c2 minus 7/4 minus 5/4. So 2c2 is equal to 12/4, which is 3. c2 appears to be 3/2. Negative 7 plus negative 5 is negative 12. Negative 12 divided by 4 is negative 3. Goes to the other side, becomes 3. Divided by 2 is 3/2. Good. So I can finally write the solution now. C1 ended up being 0, so that kills the first term, the cosine. And all we're left are 3 sine terms. For our final answer, we have C2, which is 3/2, so 3/2 sine 2t minus 1/4 sine 7t minus 5/4 of sine t, and we box this and then do the time check. Perfect, 20 minutes exactly. After Calc 2, yes. It allows me to sort out all my things in the head that I have for other things. Unleash the autopilot and just go. Because you'll scream when you see something's not good. Aha! Right on time for the second exam. Actually, you know what? This is good enough because you said you had some questions for regarding the exam. So let's end here. We'll do another example after the exam, and then take a look at circuits as well. We have to start chapter 3 last week, and go from there. So let's stop here, and I'll just make sure I'll ask you to take a look, especially, well, we'll do one of these problems, 11 through 14, and one problem from 15 to 18. They're all different applications, so we'll deal with that after the exam. Let's take a look at few problems for the exam that you have, since we still have 20 minutes to look at it. Bye, stream.